Yeah, good morning children. Welcome to my class. In this session, we will learn what is electric power, what is electric power and what is wattage and what is overloading. In our previous class, we studied Kirchhoff's current law and Kirchhoff's voltage law, that is KCL and KVL. So in this session, in this new session, we will study what is wattage and what is electric power. Next, what is overloading? What is overloading? How can we prevent our household electrical appliances and our household circuit from overheating or overloading? Okay, this is the last session of current electricity. Okay, let us consider a conductor. This is the electrical conductor. When a potential difference is applied to the electrical conductor, when a potential difference is applied across the two ends of the conductor, an electric field is generated. Here what is generated? Electric field. This electric field generated applies some force on the charges. These are the charges. These are the charges present in the conductor. So this electric field generated applies or drives the charges. Drives the charges. So the charges began to move from one point to another point. From one point to another point. So certain amount of work is done. Certain amount of work is done. Are you clear about that one? So certain amount of work is done by whom? By the electric field. By the electric field. That work done by the electric field to move the charges from one point to another point. From one point to another point in unit time is known as what we call it? Power. What we call it? Power. Or we call it as simply electric power. Or simply we call it as power or electric power. Okay. See this one. Why the electric? How the electric field is generated? On the application of potential difference. Potential difference across the two ends of the conductor. How the charges moved? Why the charges moved? The charges moved because of the force applied by the electric field. For example, this is the duster. I want to move the duster. I want to move the duster. What I have to do? I have to apply some muscular force. I have to apply some muscular force. In the same manner, certain amount of force is applied on the charges to move from one point to another point. From one point to another point. Are you clear about that one? So, how much work done? How much work done in unit time? So, the amount of work done in unit time. In unit time is called power. So denoted by P. P is equal to work done by, what is that? Time. Now work done, work is measured in joules. Time is measured in seconds. In 1 second, try to understand the concept. In 1 second, 1 joule work is done, 1 joule work is done by the electric field, to move the charges, That is nothing but power. This energy, this energy is utilized. For example, if I connect an electric bulb here between the two ends, let us assume this is the bulb. This is the bulb. So the bulb glows. The bulb glows. Are you clear about that one? Now this electrical appliance, the bulb which is connected here, consumes that electrical energy. Okay, the electrical energy consumed by an electrical appliance is known as power. We can call it as also. Okay, so what is the another definition? The amount of electrical energy consumed by an electrical appliance is called power or electric power. Okay, the units are what is that? Watts or watt. Are you clear about that one? So power is equal to 1 joule by 1 second. It means it is equal to 1 watt. Try to understand. See, if 1 joule work is done, how can you say work is done? Is there any evidence? For example, you connected a electric bulb. So the bulb glows, it gives the light energy. So how the light energy came? Because of the work done by the electrical force. If you connect to the fan began to rotate. Are you clear about that one? So we can say that electrical energy is converted to mechanical energy. If you connect the two ends to the heater, it gives the heat energy. Are you clear about that one? So certain amount of work is done. How can you say that work is done? See, the bulb is glowing, it is giving the light. At the same time, it also, after some time, if you touch the bulb, it gets heated. Are you clear about that one? So that energy is consumed by the electrical appliances. Okay, how much electrical energy is converted to light energy and heat energy is nothing but electrical power. Are you clear about that one? So power is denoted with P. What are the units? 1 watt. So what is the definition given for 1 watt? If 1 joule work is done in 1 second, then the power is equal to how much? 1 watt. Or how much energy is consumed by an electrical appliance in 1 second. The energy consumed by an electrical appliance in 1 second. The energy consumed by an electrical appliance in 1 second. So what is defined as, what is the definition given for what? If 1 joule work is done, 1 joule, 1 minute, here I am rubbing. If 1 joule work is done work is done by the electric field to convert electrical energy to light energy or heat energy, or if you connect to the fan, mechanical energy, whatever it may be, mechanical energy. Okay, so here electrical energy is converted to what is that? Light energy and heat energy or mechanical energy. That is nothing but the power of that electrical appliance. How much the electrical energy is consumed? Electrical energy is consumed. Are you clear about that one? So how this electric field that got that force? Because of the potential difference applied. Because of the potential difference applied. Are you clear about that one? So what is the unit for that one? 1 watt. 1 watt is defined as 1 joule by 1 second. If 1 joule work is done to convert electrical energy, okay, to light energy or mechanical energy or heat energy in 1 second, then the power of that electrical appliance is equal to how much? 1 watt. Okay, if you observe the market bulbs, you will find 60 watts, 100 watts, 20 watts. What does it mean? For example, 20 watts, how much? 20 joules of work is done in 1 second. In 1 second. What for this work is done? This work is done to convert electrical energy to light energy. Are you clear about that one? So the amount of work done to convert electrical energy to light energy in 1 second is nothing but 20 watts. What is that? 20 watts. Are you clear about that one? In the same manner, if you observe 100 watts is there, written 100 watts. What is the meaning of 100 watts? Means 100 joules of work is done. 100 joules of work is done in 1 second. In 1 second to convert electrical energy to light energy. Are you clear about that one? So 100 watts bulb is more brighter than 60 watts bulb. 60 watts bulb is more brighter than 20 watts bulb. Are you clear about that one? It means wattage in the sense how much electrical energy is consumed by an electrical appliance. How much electrical energy is consumed by an electrical appliance. Are you clear about that one? So electrical energy is converted to light energy and mechanical energy and heat energy. Are you clear? Do you understand the concept? Okay. Now you make a note of this. Let us derive the equation for power. P is equal to W by T. Here W is equal to VQ. Why? What is the reason? V is equal to W by Q. How we define potential difference? The amount of work done to move unit charge. Is defined as 1 volt. 1 volt. Okay. Now from this, by cross multiplication, work done is equal to W is equal to V into Q. Okay. Divided by what is that? Time, as it is I am writing. V into, this can be written like this, Q by T. Can we write like this? But Q by T is equal to how much? Current. Okay. Q by T, that is charge carried in unit time. Rate of flow of charge in unit time is defined as the current. So V into I. So power is equal to VI. Power is equal to VI. Okay, next see this one. You know that from Ohm's law, V is equal to how much? IR. Am I correct? V is equal to IR. Substitute here. P is equal to V. In place of V, you write IR into I. I into I is I square into, what is that? IR. R, it implies P is equal to I square R. This is another formula. Okay? P is equal to VI, P is equal to I square R. Next, come to this point. The same power. P is equal to I square. How can you write? V by R whole square from Ohm's law only. V is equal to IR, we studied. Okay, so I is equal to V by R. In place of I square, I am writing V by R whole square into R. V into V is V square, R into R is R square into R. Now, V square, R square can be written as R into R into R. RR gets cancelled. Now, P is equal to power is equal to V square by R. These are all the formulas to find the wattage or power. Wattage or power of an electrical appliance. Are you clear about that one? Here observe this one. Whenever resistance and potential difference is given, you have to apply this formula. Next, whenever current and voltage is given, you have to apply this formula. Are you clear about that one? Okay. Do you understand the concept? When you have to apply this formula, when voltage is given and current is given, you have to apply this formula. When resistance is given, when voltage is given, you have to apply this formula. From this you can write another formula. R is equal to V square by P. Can we write? R is equal to V square by P. So, to find the resistance of the appliance, you have to apply this formula. Are you clear about that one? So, these are the formulas to find electrical power or wattage of an electrical appliance. Are you clear? Right, make a note of it. Power is bigger unit of power is kilowatt hour. Kilowatt hour. Shortcut we write it as kWh. This 1 kilowatt hour, 1 kilowatt hour is known as 1 unit current. In our homes, we will get monthly electrical bills, 220 units or 100 units, okay, like that. So, 1 kilowatt hour is equal to how much? 1 unit. 1 unit current. Are you clear about that one? So, 1 kilowatt is equal to 1 kilowatt is equal to how many watts? 1000 watts. 1000 watts. Okay. Next, 1 kilowatt hour is equal to 1000 joules per second into 1 hour is equal to how many seconds? 60 into 60, because 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Okay. Seconds. This is equal to 1000 joules by second into 60. 60 ja 3600 seconds. Seconds gets cancelled. 1000 into 3600 joules. So this can be 5. This can be written as 3.6 into 10 to the power of 6 joules. This is equal to 1 unit. 1 unit. What does it mean? this much of energy is consumed by the appliances. How much? 3.6 into 10 to the power of 6 joules energy is consumed by the electrical appliance, whatever the appliance may be. Okay, this much of energy is consumed. Then we say that 1 unit current is consumed. 1 unit current is consumed. Are you clear? So this is the larger unit of electric power. See, joule per second or watt is the smallest unit. We cannot measure the current in 1 second. Okay, that's why we have chosen the bigger unit or the larger unit. The larger unit is kilowatt hour. In our household current is measured in kilowatt hour or units. So 1 unit means, what does it mean? 3.6 into 10 to the power of 6 joules of energy is consumed. Joules of energy is consumed by that electrical appliance. Are you clear about that one? Okay, this is all about what is electric power, what is the equation of the electric power, and what are the commercial unit of electrical power. What is the commercial unit of electrical power? 1 kilowatt hour is nothing but 1 unit. 1 unit means 3.6 into 10 to the power of 6 joules of energy is consumed by an electrical appliance. Are you clear about that one? Okay, are you clear? Right.